All right, so following along with the last question, we have a, pretty similar question, so we'll just dive on in, get it done. The statement is, derive the energy in the system of the two current carrying loops. Okay, so here we have U being the interaction energy, quote unquote. But again, we'll go back to chapter 2 on the specifics for the energy. But here what we're trying to show is that 1/2 LA squared, LA, which is the self-inductance, times the current current A squared, plus 1/2 LB IB squared, plus the mutual inductance times both of the currents is the energy in the system. Again, same system that we had last question, so this should be fun. Let's just go ahead and dive in. All right, so the solution is, we know that the power delivered to the two loops is P equal IV, okay, assuming that everything works and the resistance is consistent. This looks like the power for ohmic, but we know that power is the change in work over the change in time, so we'll just go ahead and substitute that in. dW dt is equal to, well, what is I and V here? Well, we know that V can be found from the EMF, so that's why we have negative curly EA, and then the current for A, and then we have the same thing for B. Okay, where these are changing values as the currents are turned on, not the final values. Okay, so be aware that these are changing. And we know that we can find EA pretty quickly. We've seen it kind of before. We know that we have the self-inductance A with DIA squared over, or not A squared, DIA over DT minus, of course. And then, of course, we have the mutual inductance from B, so we need to include that. Symmetry suggests the same thing for EB, so the EMF are there as accordingly. And if we go ahead and substitute them all in, what we see here is that we have dW dt is equal to negative, and then we substitute in EA. You see the negative signs cancel, times IA, and then for EB, you see the negative signs cancel again. Again, not too hard to deal with. Something about the 1/2, these 1/2 Li squared, or 1/2 something squared, kinetic energy 1/2 MV squared. It all works together somehow. But notice that every term in there has a differential time element, and so does dW. So if we factor out that derivative, since everything has it, in a linear sense, of course, now we can cancel both of them. Okay, calculus students or advanced math students will tell us that's not okay, but we're physicists, so we'll go ahead and move it through. Anyways, so this is the total work done. Then to increase the currents from 0 to their final value is 1/2 W, since we have to increase it from 0 to their max and then to their final values, right? Both of them are going to be alternating back and forth, so the average gives us 1/2. And so if we multiply it through, then we see that U is equal to 1/2 times this whole thing, and we add them together, and you see we get 2 MIBIA, that kind of thing. And it just works out the same, and you see we get the result we want. I wouldn't sweat this one too much, but a nice result to have, especially for when we deal with magnetic forces and proving that they don't do work.